Hi, ROS developers. It's Rodrigo from The Construct. And today we're going to have a student presentation from one of our students that took the ROS Basics in 5 days for Python. His name is Jiayin, and he's going to be showing us his project in which he controls a robot that we have here. So he'll be connected to the robot, and he's going to show us a program that makes the robots follow along a wall using the basics of ROS, which are topics, services, and actions. So, hi, Jiayin, how are you doing?
Yeah, great. Nice to meet you, everyone. Yeah, it's glad to share my topic, and I also thanks for the construct to give me opportunity to learn this fantastic project.
Oh, no problem. So, this is what we're here for, and we hope you learned a lot. And this is the final step for your learning today. So whenever you're ready, you can share your screen, and we can get started with the presentation.
Sure. I will start it now.
All right.
So I think I need to run the command. Yeah.
Okay. Yeah, we can see your screen now.
Yeah. So I think ROS launch, ROS basic.
Oh, you misspelled it. ROS launch.
Oh, yeah. Yeah. Shall work now. Yeah. So I started my main launch.
All right. And could you sort of just talk a little bit about what the robot is doing as it's doing it?
Yeah, so right now in the first step, he finds the closest wall, and now it reaches the closest wall a little bit to turn right. So until he faces the wall with his front, and then because it's too close, it moves back. And to adjust the position to ensure it's about 0.3 meters, and then it starts to adjust its position to ensure it's always start following the wall. So right now it's doing that. When the position is ready, he starts following the wall. So yeah, so
this is the main sort of program that's following,
yeah,
right?
Following the wall, yes. So he turn right to make sure the distance between the wall and object robot is within 0.2 and 0.3, I think. Yeah. So he moves straight, and then again he turn right. The robot start to turn right.
And do you have any output on the terminal that you've?
Yeah. Sure.
Just wondering.
I forgot. Yeah. Give me 1 second.
As we see this. Oh, great! You can put it on the side while we
So is that good?
Yeah, that's perfect.
Yeah. So it says the command turn left, and it shows the distance between the front, like 0.3, 0.4, and too close, it adjusts and moves straight forward. So that tells me how the robot is doing now.
Okay.
So whenever the right distance too far away to turn right, I think. Yeah.
Okay.
Yeah. So it continues and after that, when it finish one turn, it will stop. Yeah.
When it completes one lap.
One lap, yeah.
And
I define the one lap to be 6 meters. Maybe in real robots, is.
I think that'll be a little more than one lap, but yeah, that's okay.
Yeah, I think. Yeah, finished. Yeah.
Oh, there it is. That's
finished the task. Yeah. So I will stop the program now. Could I stop it now?
Yes, totally. We saw that.
Yeah. So I stop it.
It works.
So I close this, minimize the window and show my code. I should explain my code now.
Yes. Please go through the sections and show us how you solved it.
In the first section, I think the main point is to implement the publisher and subscriber to make sure the robot following the wall. So what I did is in this part. So in this part, in this code, I define class is called follow the wall. So whenever I do it, I define initialize functions. So here I define my follow the wall class is publisher and subscriber. So when I have a publisher which publish my command to the topic CMD velocity, and I subscribe the laser scan from the topic scan. It returns me the distance between the obstacles or the wall. So so whenever I subscribe it, I call this callback function follow wall callback. So I first define a range, and I define the right and from distance as the minimum variable within the range. So like 180 minus size to 180 plus size to be the right distance. Similarly for the from distance, and also define the minimum index and also the right index. So I also define the linear angular velocity as 0.1, 0.1. So within the safe range. So, and also have a state result. Whenever it's become 1, it means the program become active. When it's bigger or equal to 2, it means it stops or task finished. So if the state result is 1, I make sure whenever the crosswalk is closed, I slow down and turn left. Similarly, whenever the crosswalk is closer, or the white wall is close, or the white wall is far away, I define the command accordingly. I change the, yeah, so I think that's easy to understand, right? Turn left, I have a command to be 2 times angular to make it turn left quickly because the crosswalk is too close.
Yes.
I need to turn left much more quicker. But when the right wall is closed, I just need to adjust a little bit. So I make the angular velocity to be 0.6, similar for the linear velocity. So that's how I do that. And I also add one small step to be adjust and move straight forward. Even if you are within the safe range to be 0.2 or 0.3, I still adjust the position to make sure it moves straight forward. So that's how I do it. So when the robot finished, I make a command to be 0 and says finish the task. That's the first part of follow the wall. So in the second part, I was required to define a service. So whenever I call this service, I need to find the closest wall. So I do it in this part. I call it find wall class. So I first I define the twist value, and I define the service and the publisher. So, and the main difficulty would be, I think the main difficulty in this project is how to distinguish the distance between obstacle and the wall, right? So that's the main difficulty part, I think.
Yes,
so,
yes. Actually, it's one of the.
Yes.
I'm really curious because I'm seeing that you're trying to distinguish them in here, right?
Yeah. So I define a filter. It's called Hampel filter. So I will show a figure here. So in this figure, so this plot. So everyone can see this plot, right?
Yes, I can see it.
Yeah, so essentially what I do is the blue dot means the data returned by the scan topic. So the y-axis is the distance, the x-axis is the index, so it's from 0 to 719, right? So, and you can see there are several dots is far away from other dots.
Yes, the ones
so what
that
I did is,
on the line.
So the filter, what I filter do is it always returns me the dot on the red line.
And that corresponds to the wall.
To the wall, yes. So that's how I filter out the obstacle, which can be viewed as noisy. So then I always choose the minimum value to be my minimum index. So that kind of avoids me to face the obstacles. That's how I do it. Yeah.
That's amazing. That's actually the first time you said it was called the Hampel filter.
Yes, Hampel filter. I searched online and I found it's very useful. It's very simple and useful. Yeah, especially for those, because they are sound function, right? You can see it's a sound function. Because whenever the wall distance between the obstacles, between the robot and the wall should be a sound function, and they connected each other. So they should be connected, but for the obstacles, they are jumped. So this filter can count that, yeah.
Oh, wow.
Yeah, so I can go back to my main function here. So by calling this function, I filtered out this noisy belongs to the obstacles. And what I do is I return the new array index, which belongs to the wall. So then after that is easy, right? So you always choose whenever this new index is within the range, I say I found if not, I turn right or turn left to make sure it's facing the nearest wall. After facing the nearest wall, I move further away or move close to the wall to make sure the distance is about 0.3. And then I align the right side to the wall. This is the final step to finding the wall. So this is the second part. In the third part, what I do is I'm required to do an action along with my subscriber and the publisher. So what I need to do is to record all them. To do that, I initialize variables like current pose, pre-pose to calculate the distance I move, and I have the result. And I define a constant, which is the distance that I complete one lap. I say it to be 6. So and also I create the action servers to start. And then after that, what I do is in this callback function, whenever I call this action server, there's a callback function. In this callback function, I record the step. I record the distance I move in each step. So whenever the total distance is bigger than one complete lap, I see, okay, I break this while loop and update, and also I go to the success part and return the result. So they finish this part. So that's the entire project. Yeah.
Oh wow. Well, very clear. So I have a couple of questions, and I'm gonna let you still share the screen because let me ask you some questions. Okay. So right here is when the action server is what determines whether or not you have completed a lap, correct?
Yes.
And I saw that you had a state, some sort of state variable, like a flag, that determines that on your follow wall.
Yeah.
Is that what triggers the action server? Is that what does the triggering for to make the robot stop?
Yes. Whenever I finished, so if I set the succeed to, I should set that get state variable to be true. Right. So that tells my follow wall part that okay, I finished the follow task and I should stop. Yeah.
Okay. And so actually, do you mind stopping sharing your screen now? Because we can just
sure.
Go through
sure. Sure, I stop sharing. Okay.
All right. So okay, we see each other. So congratulations, Jiayin. It's very, very clear and you make it seem very, very simple. And let me tell you that something that right off the bat that has been the highlight, sort of, because I actually haven't seen it before. You were saying the most difficult part of the project is distinguishing between the obstacles and the wall.
Yeah.
Well, yes, you're right, and actually you went above and beyond that requirement because a lot of people just put the robot really close to the wall, and then just say like, all right, this is going to be the wall, the closest obstacle, and then the other ones I just don't care about, and then you just start that. But this is the first time I hear about this Hample filter, and let me ask you, how did you make that graph?
Make that graph?
Yes.
You mean the graph? I use MATLAB to plot the graph.
Okay, so you use MATLAB, and could you? We're just talking just for general knowledge. Could you talk a little bit into that? How did you put MATLAB? How did you get the data for the robot and then put it in MATLAB? How did you go about that process?
It's a very simple trick. I mean, I print all the data on my shell, and I just copy it.
Oh, you just copy, put it in MATLAB, and do.
It's very simple. Just make a quick way. I mean, the more general way maybe to output all the data to a text file. That I would say is more general way.
Yeah, the simpler the better. But
just use a simple way to do it.
Yeah, I just want to emphasize on that because a lot of students don't know about this, and this just increases the level of the project, and with this filter, now you actually absolutely know the difference between an obstacle and the wall, and then you
Yeah.
can keep building on top of that to make an application. I don't
Yeah.
know that does something depending on the obstacles or depending on the wall, but because
Yeah.
now you have them separated. So I love that. That was great. And let me see what else I wrote down. Oh yes. All right. So the thing that I didn't see actually was the odometry output of the how much it. Oh no, but
Oh,
it
yeah.
moved because it moved 6 meters. So I'm guessing like it was recording the odometry.
Okay. Oh, yeah. I will show the code actually. I do that part.
Okay, no, I trust you, but I don't remember seeing it. But that was the other thing. And let me ask you, thinking about this 6 meters,
Yeah.
and I don't know, are you experienced in ROS?
Yeah. I do it in simulation. I test how long it is in one lap.
Right. Okay. So
Just yeah.
how? I guess I'm trying to ask you if you know of a more precise way to finish that one lap instead of kind of
Oh yeah.
eyeballing how much that length is. Is there anything you can think of that
Yeah.
could make it more precise?
Yeah. Because Automate returns your pose. Whenever the pose is very close, I say finish one.
Mm-hmm.
That's another way. Yeah.
Yeah, yeah. I mean, this is not required, but I'm just
Yeah.
trying to uh, showcase like always like little things that you can
Yeah.
keep improving to make your code less hard coded. And this is just for the students that are watching that are interested.
Yeah.
Um, you can always keep going and improve it. But uh, other than that, Jiayin, I thought this was the one of the better projects because of the simplicity and how you explained it. And the star of the show was that hamper filter that I'm
Yeah.
definitely going to take a look at because it's going to be very helpful for me and for things that I do because I'd never heard of it. And
I just Google it. I thought maybe useful. I test many code in MATLAB. They provide the function called hamper and test on my result. I noticed that it's very good in this case because they are piecewise
yeah,
sign function. They should be connected. It has some pattern actually.
right. So it's based on the pattern of how so if there was an obstacle that was really long, for
If
example,
there are obstacles, it will jump because the obstacle distance, because for the wall, the distance should be connected, right?
yes,
They're
yes.
continuous. They are continuous. They cannot jump. But for
Mm-hmm.
the obstacles, when you scan an obstacle, it must jump. There's a pattern there.
So what if there was a hole in the wall? Would it be considered an obstacle in that point, or
A hole? You mean a hole? Okay.
like let's say like the wall, the wall, the square
Okay.
wall, like had an entrance, let's say, or an exit for the robot to go charge itself or something. Would that filter be useful in that case?
That means I need to have I need to interpolate. I think I need to interpolate.
Okay, okay,
Interpolate
yeah,
between
interpolate,
them, right?
yeah. Okay.
That's another way to solve the problem.
Mm-hmm.
I need to interpolate, then return me some fact, some the fake distance. Says okay, assuming there's a wall. I can use maybe Gaussian process to interpolate, or
Right.
even polynomial interpolator. That's more
Yeah.
easier.
Yeah, that sounds like a good way to do it.
Yeah,
Um, but I mean, other than that, I mean, congratulations again. You passed with flying colors, and just for everyone else that's watching, this is what you can do and what you can showcase. In this case, Jiayin is teaching me things, so it's always a good way to the last step to showcase what you've learned in the course, and this is what we're just trying to provide. So if you're taking the course, make sure you attempt the the project here like Jiayin has done. And we hope to see you again, Jiayin, for more projects and for more
Yeah.
cool things you're going to be developing. So thank you very much, Jiayin.
Thank you. Yeah, thank you for the construct, give me this platform to learn ROS. Yeah, I will say thank you. Yeah.
No problem. So we'll see you around, Jiayin. So
Yeah.
bye-bye.
Bye.
All right. Okay, I finished the stream.